Hi, this is Alex from devstories.eu. Docker Masterclass, Episode 6 of 18. Shipping your compiler to production is a massive security risk, and it inflates your container size by gigabytes. You write clean code, but your final artifact gets dragged down by all the heavy tools needed just to build it. The solution to this is multi-stage builds. When you build applications in compiled languages like Java, Go, or C++, the compilation process requires build tools, software development kits, and raw source code. Historically, developers used a standard approach where they installed all these dependencies into the container, compiled the code, and then ran the application. The problem is that all those build tools remain in the final production image. You end up deploying your compiler, your package manager, and intermediate files alongside your actual application. This makes your container enormous. Large containers take longer to pull across the network and consume more storage. Even worse, it creates a massive attack surface. If an attacker breaches your container, they suddenly have a fully equipped development environment at their disposal. A common misconception is that fixing this requires maintaining two separate files, one file to build the software and a script to extract the result and pass it to a second file for deployment. That is not the case. Multi-stage builds handle this entire separation of concerns inside a single file. Here is the key insight. A multi-stage build allows you to define multiple distinct environments or stages sequentially. Each stage begins by defining its own base image. You start the first stage with a heavy base image that contains all your development tools. You assign this stage a name, such as Builder. Inside this Builder stage, you copy your source code from your local machine and execute your compile commands. The Builder stage does the heavy lifting, generating the final executable file. Then, further down in that exact same file, you define a second base image. This initiates a brand new stage. For this stage, you choose a minimal runtime image. This environment only contains the exact dependencies needed to run the application, with zero build tools. Instead of copying files from your local machine again, you use a specialized copy instruction. This instruction tells the build engine to reach back into the builder stage, grab only the finished compiled artifact, and drop it into your new minimal stage. When the build engine finishes, it produces a container based solely on the final stage. Everything from the first stage, the compiler, the downloaded packages, the source code, is completely discarded. It never makes it into your production image. Consider a concrete scenario involving a Java Spring Boot application. In your Docker file, your first stage uses a bulky Maven image. Inside this stage, you run the Maven command to package your application. Maven downloads all necessary project dependencies, compiles the Java code, and packages it into a finished jar file. Next, you start the second stage using a lightweight Java runtime environment base image. You do not install Maven in this environment. You do not copy your Java source files here. Instead, you instruct the engine to copy only the compiled jar file directly from the Maven stage into this minimal runtime environment. Finally, you set the default command to execute that jar file. By strictly separating the build environment from the runtime environment, you guarantee that your production container is completely isolated from your build tools. The final image only ever sees the compiled artifact and the bare minimum runtime, keeping your deployment fast, lean, and highly secure. That is your lot for this one. Catch you next time.